So now we have a basic character controller set up. Our character can walk around, they can look around based on the mouse or a controller, whatever you chose. And we got the animations working. We got our running animations working. In this video, we are going to focus on first setting up their dying animation. We're not going to like code a death mechanic just yet because we don't have enemies. But let's set up the dying animation. Let's just get it into our animation blueprint and working somehow. And also, let us set up a walking state. So just like our first person character, we are going to walk slowly when we test WSAD, and when we hold shift, we're going to start sprinting. And the reason I'm setting this one up is just to show you guys how animation states work and what they are conceptually. And in the next video, finally, we will set up the gun model for our character. We'll also just set up the basic shooting animations. And this will like prep us and get us ready to do the actual logic part of it, when they shoot. But we'll have the animation set up since we're already just working with animations. It's good to just let's keep the momentum going and set everything up right now. So to start, let us download the animations we need for this video. I already have Mixamo open up and I have already downloaded all these animations. But what we're looking for is some walking animations. So I have just searched walk. And there is a walk pack where there's walk forward, left, back, and right. Here's walk forward. Here's walk backwards. I'm sorry, this is walk left. And somewhere there's walk back and walk right. But they're all part of the same pack. You can tell our character is still holding the rifle. And I'm going to use this because this is just going to make everything simpler for us. So again, we're going to download walk forward, back, left, and right. Make sure when we hit download, we download it without the skin. We already got the skin. And the other thing I'm going to search for is dying. Now you can pick any of these dying animations. It doesn't matter because it's going to override our animation completely. The character is just going to fall over and die. We're not going to be allowed to control the character anymore. And there's not going to be any blending happening. We're just going to go from walking or shooting, whatever your character was doing, into death. So feel free to pick any of these death animations and then just download it, again, without skin. With our animations downloaded, let's go back to the engine. And let us go into our animations folder. And just to keep things organized again, I'm going to put the running animations into their own folder. And make a new folder for our walking animations. Okay, so I'm going to take all these animations. I'm going to leave dying and clapping. I'm not sure why I downloaded that, but let's leave those two out of it. And let's just drag the walking animations. Make sure that we set the right skeleton and import it. While we're at it, I'm also just going to import the death animation since we already are here. Let's just drag the death animation so we don't have to do it later. Awesome. So what we're going to do first is, just like we had for our running, we have a blend state somewhere. Yes, this run blend, blend space, sorry. We have this blend space for our running. Let's make one for our walking as well. So under animations, let's go in walking and make a blend space. This is going to be the exact same blend space that we did for the running. So I'm just going to quickly make it so we can continue on. So I'm going to call this walk blend. And just real quick, just set this up for us to use. Okay, now that we have our blend space working, this is the exact same type of blend space for the running. Let's go ahead and incorporate this into our animated character. To do this, we are going to go into our animation blueprint. And let's talk about a new concept in animations. So right now, all we're doing is we have these two variables. We're driving these two variables in our tick event by getting the player's velocity. We did a little math on the velocity. And we're just setting this to our blend space, and it's setting the run blend space. But really what we want to do is we want to have our character be in two different states. We want a walking state and a running state. In the walking state, they're going to do the exact same thing, except with the walk blend rather than the run blend. And in the running state, they're going to use the run blend. To do that, and really to do a lot of complicated animations, we are going to need something called a state machine. To make a state machine and to see what it is, all we do is we right click and we search state machine. It's going to ask us to name it. This state machine is going to transition our walking and running, our movement really, so our locomotion. So I'm just going to call this state machine locomotion, so that we understand that this state machine drives our walking, running. You know, if we had crouching, it would be that as well. But it runs those kind of states, things that involve our movement. So real quick, what is a state machine? The idea of a state machine is fairly simple. It is a little collection of states, so to speak. Spaces our character can exist in. They can be either in the walk state or the run state. In our case, these are two states. And this state machine will drive the logic of that switching. So when do they switch from walk to run? When do they switch from run back to walk? In any state machine, the machine can only be in one state. So we can't be in the walk state and the run state. We can be in either the walk state or the run state. And that's just the basic of all finite state machines, which this animation state machine is one of. Our use of this is going to be fairly simple. We're going to make a walking state. We're going to make a running state. And our character is just going to switch between those two states depending on whether they are holding the shift key or not. So let's start by making a new state for the walking. If I just drag a line out of this entry is where the state machine starts. I'm just going to write and add state. I'm going to call it walking, or just walk. And now we need another state, so just drag out of here, add state, and we'll call this run. Okay, so before we get into it, let's just look at what these things mean. So entry, like I said, this is the entry node. Our entry can only connect to one state. So if I plug it in, if I was to plug it in here, you can see that it doesn't plug in here anymore. It went to run, but I wanted to go to walk on entry. When our game starts, it's just going to go through entry and go into the state that it's plugged into. Then we have these lines here that goes from walk to run, including the line from entry to walk. These are called transition lines. So these are the lines that our state machine can transition from. So from walk, we can transition to run. And currently from run, we can't transition anywhere. And we know this, or we can see this because this arrow only points in one direction. So what we want is for run to also be able to transition back to walk. So we can click out of run and drag an arrow back here. So now we can read this as walk. We can transition from walk to run, and we can transition from run back to walk. These transitions have certain rules. If we click on this little button here, we can change some parameters of the transition, and these are usually things like the transition time, the duration of like the animations playing. Maybe you want an animation to finish before it transitions back. These are all settings we can set here. For our case, we don't really need to touch any of those, but it's good to know. There is a lot of settings we can do with the transition on how these two animations are going to blend between each other. The other thing state machines need for these transitions is a condition. We need to know when we're going to transition from walk to run and when we want to transition from run to walk. Really, what we want to do is we want to transition from walk to run when we're holding the shift key. So if we're sprinting, quote unquote, and if we stop sprinting, if we let go of the shift key, we want to go back to walk. We can keep track of this using a variable. It's just going to be a Boolean, and I'm going to call it is sprinting. And in other words, I can't drag this out here, but if is sprinting is true, I want to transition to the run state from the walk state. If is sprinting is false, I want to transition from the run state back to the walk state. In the side of our, in the left side of our window here, under the animation graphs, we can see this new, there you go. We can see this new state machine we created here, locomotion. And we can see there's two states and there's two rules. There's walk to run, that's a rule. That is this transition line right here. And there's run to walk, which is this transition line on the right, going from run to walk. We can double click these and we can see the result of our rule. It opens up like a new function. And I'm going to click on walk to run first. So going from walking to running. We want to do that when is sprinting is true. So I can just plug is sprinting into here, because if is sprinting is false, this is also going to output false. Now from run to walk, I want it to be the opposite of is sprinting. So if is sprinting is true, we don't want to run. If is sprinting is false, then we want to run. So instead of just plugging it in directly, we're going to use a not operator. So we're going to do is sprinting, the opposite of that, and then plug that in. So if is sprinting is false, the opposite of false is true, so this result will be true. When we start sprinting, the opposite of true is false, so this result will be false. So when we're sprinting, we can't go from run to walk. When we hit the sprint button, we want to go from walk to run. Okay, so with those rules set up, we now just need to set this up in our player. Again, to communicate between the player and the animation blueprint, we are going to use a BPI. So in our player BPI animation, I'm going to add a function and call it is sprinting. Or, well, we have a variable called is sprinting, so let's just call this player sprint. And this needs an input because we're going to pass this along from the player to the controller. So this input's going to be called is sprinting. And we can leave it as type Boolean. Let's open up our player blueprint now. And because we implemented this interface, we have a player sprint there. I have not made a button press for my sprinting. So for this tutorial, I'm just going to use the input keys, the keyboard keys event. But ideally, we'd be using the new input system and making a sprint action for this. I don't have one, so I'm just going to use this for now, for simplicity's sake. Okay, so what we want is when we're sprinting, we want some variable, or we want to set this BPI player sprint. We want to call this function and set it to true. And what do we want to call it on? Well, we need to call it on our player blueprints, on our BP Twin Sticks animation blueprint. So first we need to get access to that animation blueprint. And to do that, all we need to do is pull out this mesh component, because the mesh is the one that contains the animation blueprint. And we can just search get anim. We can just search get anim instance. Oops, not that one. Get anim instance. There we go. And with this, we can run our function that we made. We called it player sprint, so let's call that player sprint. There it is, BPI animation player sprint as a message over here. And we want to call the same function again. When we released, when we press it, we call is sprinting as true. When we release it, let's call it as false, and then make sure to plug the target in. Finally, before we leave our player blueprint, let's actually change the speed of our player to match this. So I'm going to get the character movement controller and do set max walk speed. Again, this is the same as our sprint function from our first person game. The only difference is get animation instance. Now we're passing it along to the animation controller. So I'll make their walking speed 300 and make their sprinting speed 600 because it looked good with the animation. Make sure to plug the target in. And finally, let's just set our player's default walk speed to 300 to match their walking speed. So real quick, before we even do the animations, let's just make sure our walking speed thing is working. They're walking pretty slowly, and oh, I think I just flipped it around here. We want their walk speed when we're holding shift to be 600, when we let go to be back to 300. Okay, let's check that again real quick. Okay, that works fine. So we have this function set up now. We are passing this is sprinting variable along to our animation blueprint. Let's make use of it in the animation blueprint. So in our animation blueprint, under interfaces, we have player sprint. Let's just double click, which adds an event, player sprint. And we just want to set our is sprinting to match that. And before we test it, let's go back to our animation graph. And we were using just this run blend. Instead, let us now use our state machine. And we should be... Oh, actually, the last thing we forgot to do was actually set up the state machines themselves. If I was to double-click and go in here, we can see our little state has its own output pose. And really, we have two states, right? Two output poses. We have a run state and a walk state. Our run state is fairly simple. I'm just going to copy this run blend and go into our run state and paste the run blend here. Because when we're running, we want to run this run blend. For walking, instead of using the run blend, I am going to go and get our new walking blend. And then just plug these things in. And now this should work. It should be ready to work. It should be ready to test. Let's go see it working. So now my character is walking. They're walking nice and slow. It's playing the walking animation. And the moment I hold shift, we start running. When I let go of shift, we walk again. Okay, so that was like a good switch over. We have added another feature of sprinting, but really I wanted to show you guys how we can use state machines to drive our animations rather than having a messy graph here. We have it split into two states, and each state can just run its own piece of code. All we have to tell Unreal is when do we want to switch our states. Again, this is a fairly simple animation. You can imagine adding a crouch state is as simple as just adding another state here, you know, creating a new state for crouch, where we do basically the same thing, but on a crouched walk animation. And the crouch animation should be able to transition back to walking or sprinting. Depends, again, how you have it set up. Some games would have not just a crouch walk, but also a crouch run animation, both, you know, separate. But again, that is the whole point of these locomotion state machines, is we can very easily start adding new movement options without messing with the entire animation graph, because every state is nice and separated. Our player can only occupy one of these states, and we can transition between them as needed. Let's do one more thing for this video. Let us also set up a death animation. So I have the dying animation out here. We downloaded this dying animation, where a player just falls over. Let's add this to our graph. Right now, we're not going to have any like logic that's going to drive the dying. I'm just going to make a button press do it. And later on, we can, you know, add some logic that actually, when our enemies touch our player, the player dies. So let's go back to our animation graph. Currently, we have this locomotion going on. The death animation is going to override the locomotion. It's going to be its own animation that we play. I can just drag it in as a sequence for now. And really, the player is going to be walking, 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 and when they die, we want to play the death animation, like that. The whole body is going to play it. And we don't really need to blend between them. We can just switch to the death animation when it happens. And we also don't need our death animation to loop. So to switch between animations, the easiest way to do this, there's no real like branch node in our animation graph, but we can use something called blend poses. We can consider this locomotion one pose. This is the output pose. So these little people variables, they're called poses. So we can blend between this pose and another pose. If we search blend pose, there are a bunch of blend poses available to us. We scroll up, we should see the correct ones. Blend poses by, yeah, we're looking for this one. Blend poses by Boolean. And this is because our blend is just a true or a false. So if it's active, if it's true, it's going to run this true blend pose. If it's false, it's going to run the false blend pose. Whatever the output pose is, let's plug that in. And for dying, I'm going to make a Boolean called isDead. And if isDead is true, that means our player is dead. And all I'm going to do is, if they are dead, let's play the dying animation. And if they're not dead, let's continue playing the walking animation. So we can see that in the works here. So I don't have isDead is true. This active value is not true. Our player is currently doing the idle animation. If we turned active value to true and compiled it, they play the death animation. So just like we set up the sprinting button, for now I'm going to set up a button to do this. All I'm going to do is get isDead and set it to our variable here. And let's go ahead and make another BPI function. So we made player sprint. Naming convention to keep it similar, I'm going to call this player death. And same thing. This is going to take an input, and it's going to take isDead. Again, we don't have logic to test this, so I'm just going to use a keyboard key. I'm going to use the keyboard key, maybe T. Let's just do it like this. So when we press the T key, I want to call this function. So just like we got the anim instance here, let's get the anim instance, and let's call player death. Make sure it's the message function. And when we press the T key, we want isDead to be true. We're not going to have like any logic to help us reset the game right now or anything. So when we're just going to do it one time, the player is going to die. The other thing we also need to do is disable our player input. And because our rotation, our mouse rotation happens on tick, we need to disable that rotation as well when our player dies. So I'm just going to move everything to the side. I am going to make a new variable in our player and call it isDead. And we'll set that variable as well, so that when we die, we can stop our rotation. So let's see if all this worked. We can move around, we hit the T key, we can't move, but we didn't play the death animation. Right, and that's because we just haven't used the BPI's function here to actually set the variable. Like we have event player sprint setting is sprint, we haven't done that with player death. So let's just do that. That's it, sprinting isDead. Okay, now it should work. So let's compile this, go and hit play. We can run, we can sprint, and we hit T, and our player dies. And then at some point, we would just reset the game, set this isDead variable back to true, give our player our input back. That part should be fairly simple. Or alternatively, a little easier way of doing all of that is just restart the level. Either way works. But now our player dies, and later on, we can figure out some logic of when we want them to die rather than just pressing the T key. Anyway, this video has been about how we can set up our player animations a bit better. We've gone over state machines. We keep using this BPI to communicate between the player and the animation graph, which is a good way of doing things. And we've also set up our animation graph just a little bit better. We've added some more versatility to it. We now use a state machine for our locomotion, so we can support different types of locomotion. And we also just added a simple dying sequence, and we just blend between that and our locomotion based on this is dead variable. In the next video, we will set up our weapon, we'll set up our shooting mechanic, not the code part of the shooting mechanic, but the animation part of the shooting mechanic. Thank you for watching.